Okay, good day everyone. So today we are going to discuss our class syllabus for our fundamentals of electronic circuits course. So you may be wondering what is the difference between the fundamentals of electrical circuit course and the fundamentals of electronic circuits course. So for the fundamentals of electrical circuits course, we are actually dealing with a much more on larger scale electrical systems like large scale production and distribution of electrical power, while in our electronic circuits course, we are actually focusing on much smaller circuits because what we're trying to do is we are trying to control the flow of electrons. This is for electronic circuits. We are trying to control the flow of electrons in order to perform a task, while for our electrical circuits course, we are trying to transform electrical energy into other forms of energy. For example, we want to have electricity to become light or sound or heat. So that is the focus of electrical or the fundamentals of electrical circuits course. So that is the difference between the fundamentals of electrical circuits course and the electronic circuits course. These courses are actually allied courses for the Bachelor of Science in Computer Engineering program, which is your program that you're studying. So, in addition to this, no, electrical devices convert electrical energy into other forms of energy, while electronic devices control the flow of electrons, as I have said earlier. So, so to repeat what have been said, or to summarize, our electrical circuits course focused on the transformation of energy, while for electronics, it focuses on the flow of electrons, a more specific control on the flow of our electrons. Okay, so for this course, the fundamentals of electronic circuits, this course discusses the construction, operation, and characteristics of basic electronic devices such as junction diodes, bipolar junction diodes, field effect transistors, and most field effect transistors, as well as the oscillators. Okay, so we have here the term junction diodes. What exactly is a junction diode? A junction diode is one of the simplest semiconductor device. It has the electrical characteristic of electricity or current passing through in one direction only. Okay, so for our junction diodes, the junction diodes let the current through in one direction only. Okay, so unlike a transistor or unlike a resistor, a diode does not behave linearly with respect to the applied voltage. Instead, it has an exponential current voltage relationship, and therefore we cannot describe its operation by simply using an equation such as Ohm's law. I know in your electrical devices circuits course, that is one of the focus of the course. Okay, the Ohm's law, the other laws with regards to electricity, no? But here, dun sa junction diode natin, we already have relationship that cannot be described by the Ohm's law. Okay, so the key thing to remember here for junction diode is that it enables the passing of the current through one direction only. Okay, so we have another term here, which is the bipolar junction transistor. So what do we mean when we say bipolar junction transistor? So a bipolar junction transistor, which is also known as BJT, we are going to call that BJT during our course so that we will not call it on its lengthy name, the bipolar junction transistor, or maybe We may even call it as BJT transistor, even if the T is redundant, just to know that it is a transistor. Okay, so a BJT is a three-terminal semiconductor device consisting of two PN junctions, which are able to amplify or magnify a signal. So it is a current controlled device. So it is a current controlled device. So when we say current controlled device, actually, because as you know, transistors are actually kind of switches. For BJT, this is a current controlled device, which means that it switches or it triggers using current rather than voltage. Okay, so the three terminals of the BJT are the base, the collector, and the emitter. I know that you already know some of this during your electrical circuits course. Okay, so the BJT is a type of transistor that uses both electrons and holes as a charge carrier. A signal of small amplitude, if applied to the base, is available in the amplified form at the collector of the transistor. Yes, because that is what we mean when we say amplification. We want to put a small signal and amplify it or magnify it so that it will become a larger form of that signal. Okay, so that is what a BJT does. Okay, so take note that a BJT does not require an external source of DC power. Just like to carry out the amplification process, no, we do not need an external source of DC power, unlike other amplifiers that we use or you have used probably in your fundamentals of electrical course, circuits course. Okay, so that's what we mean by BJT. The key thing to remember there is that BJT is a transistor with two PN junction which are able to amplify or magnify a signal. Okay. Another thing we have here is the field effect transistor. So for the field effect transistor, it is a type of transistor commonly used for weak signal amplification. Okay, the device can amplify analog or digital signal. You can also switch this function. You can also I'm sorry. You can also use this uh, we field effect transistor for it to become an oscillator. Now I know that this might be a little confusing right now, but as we go on, as we discuss through this subject course, we may be able to understand what has been said on this introduction. Okay, so that is the utility of our field effect transistors. Another term is that we have our MOS field effect transistors or our MOS field effect transistors. So for the MOS field effect transistors, of course, as in the name, it is still a field effect transistor. So it's still a FET device. So what is the difference then between the MOSFET or the MOS field effect transistor and our field effect transistor? So in MOS field effect transistor, we have what we call our metal oxide semiconductor. So the primary use of MOSFET is to control conductivity or how much electricity can flow between its source and drain terminals based on the amount of voltage applied to its gate terminal. So the main difference between our FET or our regular FET and the MOSFET is that the MOSFET or the MOSFET have a much higher input impedance. Okay, another is that they have high drain resistance due to lower resistance of the channel, and another is they are easier to manufacture and they support high speed operations compared to our regular FETs. So that is why this is one of the most commonly used transistor today, our MOSFET. Okay, so we have another term here, the oscillator. So the oscillator is actually pretty basic. When we say oscillator, an oscillator is merely a mechanical or an electronic device that works on the principles of oscillation. For example, a periodic fluctuation between two things based on changes in energy, such as computers, clocks, watches, radios, and metal detectors, are among the many devices that use oscillators. Of course, when we say oscillator, we have the mechanical, as had been said earlier, we have the mechanical and we have the electronic device oscillators. Of course, in this course, we are going to focus on the electronic device oscillators. Okay? So the next thing we have here is the goals of this class. Okay, so the first one is for the students to familiarize themselves on the basic electronic principles. Okay, another is to analyze the different circuits and models at high frequency. The third is to analyze and solve problems with regards to transistor circuits. And the fourth is to analyze combinational and sequential devices for logic circuits. Okay? So the next thing we have here is the evaluation. Of course, how am I going to give you your grades? Okay, that is what we mean when we say evaluation. So we have four evaluations. We have our recitation, our project-based evaluation, our quizzes, and our examination. Of course, the examination is one of the most important evaluation that you will have. So you must be able to pass that evaluation. Okay. For the project-based evaluation, it is usually at the end of the term or at the end of this course. You will need to apply what you have learned in the course into a small project output. That means it's probably you're going to create a device of your own that uses the topics or that uses the knowledge that you have learned during your fundamentals of electronic circuits course. Of course, the recitation is what will happen during our classroom discussion, no? And the quiz is what happens after each and every subject topics that we have. Okay, so that is how I will evaluate or assess you, and that will be the basis for your grades. Okay, so the lessons to be covered here, of course, we have number one. This one is for the prelims. We have the solid state. Another is the semiconductor p-n junction diode. The third is the diode circuit analysis and application. So that is for our prelims. For our midterms, we have the bipolar junction transistors and the field effect transistors. For semifinals, we are going to talk about the resistor transistor logic, the direct coupled transistor logic, the integrated injection logic or our I2L, and the Schottky diode non-saturating logic or the Schottky diode non-saturating logic. My apologies. Okay, so for the finals, we have the emitter coupled logic, the MOSFET logic comparison of different logic families, and the oscillator circuits. Okay, so we have the four. Again, we have the emitter coupled logic and the MOSFET logic, and then the comparison of different logic families as well as the oscillator logic. Okay, for the requirement for this class, the student must take and pass all the tests, the examinations. Okay, so of course, you will need to have a grade for the examination greater than 75%. So that is our basis. So if you fail the examination, it is of great chance that you will also have a failing grade. Okay? Another is for you to have graded recitation. So whenever we are discussing, it is highly recommended. Okay, no, it is a requirement. It is not highly recommended. It is a requirement for this class for you to also recite, participate. Okay, You must be able to participate during our classroom discussion. So, how are you going to participate? You must review first before you enter our class. Okay, that is one of the most important thing that you can do. Do not go to class not knowing anything. Okay, so sir, you are the teacher. Aren't you supposed to teach us? Aren't you supposed to give us your knowledge with regards to this topic? With regard to this topic, of course, I will do that. But it's also nice for you to be able to participate in a way that you already understand the subject matter. That will make the class more interesting for your classmates as well as I, so that we may converse as if we are already professionals on our fields. Okay, so the next we have is okay. There is no more for this slide. So I think that's the end of our course guide or our class syllabus, summary of our class syllabus for the fundamentals of electronic circuits. Okay, so that is it. So that is it for our introduction for the course. So I'm expecting everyone should review already the topics covered prior to our entrance for our next meeting, which is the solid state topic. Okay, I have given you a copy of the class syllabus in your group messenger. So hopefully you will be able to look into the topics for prelims already. Okay, so that is the end of our introduction to fundamentals of electronic circuits, or the introduction to the syllabus for this course. I hope everyone have a nice day and goodbye. Okay, bye.